Good morning, students. Welcome to Computer Aided Design course, course code P20DE102, week 2, classroom discussion topic on wireframe models. I am Rakesh, Assistant Professor in Department of Mechanical Engineering, KITS Warangal. Before going to enter this topic, let us see the lecture outcome for this topic. After completion of this lecture, student will able to learn the following lecture outcome. Discuss the importance of wireframe models in CAD/CAM. A wireframe model of an object is the simplest geometric model that can be used to represent it mathematically in the computer. It is sometimes referred to as a stick figure or an edge representation of the object. The word wireframe is related to the fact that one may imagine a wire that is bent to follow the object edges to generate the model. Typically, a wireframe model consists entirely of points, lines, arcs, and circles, conics and curves. Here conics means like parabola, hyperbola, ellipse, etc. Wireframe modeling is the most commonly used technique and all commercial CAD/CAM systems are wireframe based systems. These wireframe models, these techniques are developed in the year of 1960. In the year of 1960, they introduced only two-dimensional wireframe models. It contained enough useful information to perform the numerical control work. Users had to construct geometry in the desired various views like front view, top view, left side view, right side view, back view. It consists of 6 different types of views independently due to the lack of centralization and associativity of the resulting database. Later in the early of 1970s, the centralized associative database concept enabled modeling of three-dimensional objects as wireframe models that can be subject to three-dimensional transformation. Here, transformations like translation, scaling, rotation, reflection, and reflection. In constructing a wireframe model on a CAD/CAM system, the user should follow the few modeling guidelines. The detailed step-by-step procedures to create models may vary according to system capabilities and the user's individual habits. In addition to the commands required to create the common wireframe entities, users are provided with other tools that facilitate the model construction. These tools in general help user to manage geometry as well as to avoid unnecessary calculations. For example, typical CAD/CAM system provide users with possibly three modes to input coordinates. Here, three different modes are Cartesian coordinates, cylindrical coordinates, and spherical coordinates. Each mode has explicit or implicit inputs. In the next lecture, we will discuss what the difference between explicit methods and implicit methods. We will discuss in wireframe entities. Here, explicit input could be absolute or incremental coordinates. Implicit input involves users' digitizers. Another example is the geometric modifiers, which automatically identify specific locations such as endpoint or midpoints of entities that are convenient to access once these entities are created by the system. For example, you can draw the one line in AutoCAD. It's showing two endpoints and one midpoint. For example, you need to draw one circle. It's showing four nodes and one center point. For example, you need to draw one arc. It's showing 3 points on arc and one center point. Uh, Let us discussing about advantage of wireframe models. The major advantage of wireframe modeling is its simplicity to construct. Simple to construct. Therefore, it does not require as much computed time and memory as the surface or solid modeling. However, the user or terminal time needed to prepare an input data is substantial and increases rapidly with the complexity of the object being modeled. Here, wireframe modeling is considered a natural extension of traditional methods of drafting. It does not require extensive training of users. The next one is it forms the basis for surface modeling as most existing surface algorithms require wireframe entities. Here, wireframe entities are points, lines, and curves to generate surfaces. Lastly, the CPU time required to save, edit, or update a wireframe model is usually small compared to surface or solid models. A wireframe model of a box offers a typical example where the model may represent more than one object depending on which faces is assumed to exist. Models of complex design having many edges become very confusing and perhaps even impossible to interpret. To overcome this confusion, lines can be hidden, dashed or blanked. If done manually, these operations are very tedious, error prone and can result in nonsense objects. In some softwares, it providing automatic hidden line removal algorithm based on wireframe modeling are usually helpful. For example, a representation of a hole or a curved portion of the object. You can see this figure. In the first figure, it's showing no edges displayed. In the second figure, showing one edge displayed. In the third figure, it's showing user created edges. That means these two circles are connected with two tangent lines. Representation of a hole or a curved portion of the object. In most systems, the hole is, you can see the first figure, the hole is displayed as two parallel circles separated by the hole length. Some systems may connect a line between these two circles. You can see in the second figure, one edge displayed. In many cases, users add edges of the hole for appearance purpose at the drafting mode or may use cylindrical surface to represent the hole which introduce problems later and during the model cleanup phase. In adding edges, inexperienced users tend to attempt to create tangent lines between the whole circles, which obviously does not work. Let us see the limitations or disadvantages of wireframe models. First one is these models are usually ambiguous representation of real objects and rely heavily on human interpretation. The second one is the input time is substantial and increases rapidly with the complexity of the object. Uh, Creation of a simple box as a wireframe and solid. Uh, the location of one corner, the length, width, and height are the required input, while in the former the coordinates of at least four corners of one face. The depth and edge connectivity are required in wireframe model for considering the box as a two and a half dimensional object. Uh, Here the important point is in both topological and geometrical data are needed to construct wireframe models while solids require only geometrical data. From an application and consequently engineering point of view, wireframe models are limited use. Unless the object is two and a half dimensional, volume and mass properties, NC tool path generation, cross-sectioning and interference detections cannot be calculated. The model can be used in manual finite element modeling and tolerance analysis. From an industrial point of view, wireframe models may be sufficient to many design and manufacturing needs. From a practical point of view, many companies have large amounts of wireframe databases that are worth millions of dollars and man hours, and therefore make it impossible to get rid of wireframe technology. This is the brief discussion about wireframe models, advantages and disadvantages of wireframe models. Also, we discussed about one example, that is displaying whole and curved ends in wireframe models. The lecture outcome is having completed the discussion on wireframe models, the students should able to uh, learn the following lecture outcome, that is discuss the importance of wireframe models in CAD CAM. For more information, the students are required to refer the following textbook, that is Ibrahim Jeet and Shiva Subramani RR CAD CAM Theory and Practice, second edition, New Delhi, Tata McGraw-Hill 2010. The reading chapter is 4.2. You can also refer the following reference book, that is Ibrahim Jeet Mastering CAD CAM, first edition, New Delhi, McGraw-Hill, Higher Education 2010. Thank you for watching.